In this session, we'll go through some advanced throughput topics. We've already talked about how the throughput test works. It's a binary search. Now, there is another option here called the O-load search option, and reminding you that there are O-loads, offered loads, there's I-loads, intended loads, and there's the forwarding rate or achieved load. Just as a short reminder here, an intended load is what the throughput test programs into a card and asks the card to attempt to send. The offered load is the traffic that gets onto the network under test. So if we are, for example, doing an upstream test, the intended load on a Wi-Fi card could be 100,000 packets per second, but the offered load is only going to be the packets that are acknowledged once they've been transmitted, and that'll govern how many packets per second actually get out onto the media, right? So in the upstream direction, what we find is that once the access point is acknowledging all the frames per second that it possibly can, increasing the intended load does not result in an increase in the offered load. And so we can shorten the test by selecting the O-load search option and say increase the intended load only when the offered load increases a certain amount. Now let me set this to 1% just so that we can watch it work once. And we'll do a test in the upstream direction. We'll do that 15, 18 byte frames, start at 50%. And remember what we were seeing was as we were running in the upstream direction, the intended load would go up and up and up, but the offered load wouldn't. So let's run that test once, make sure that we don't have the hardware log set. We connect up like we always do. We ARP through. So we set it back to only one client on the Ethernet and one client on the Wi-Fi side. So we run at 50%. We achieved a load of 39,000 packets per second. The second time we achieved a load of 77,000 packets per second. Okay. Notice it quit very quickly here. So in the upstream direction, the second time we were at 100%. And it passed with an achieved load of 77,000 packets per second, right? So the offered load and the achieved load ended up being the same thing. So then the I load got set to 125%, right? Which was attempting 98,000 packets per second. But given that we'd already maximized how much traffic could get onto the Wi-Fi interface, you can see that the achieved load really didn't go up that much at all, right? Because we were already very close to the theoretical max. So what it did was recognize that the load achieved did not go up that high. The O load did not increase at more than 1%. So it went ahead and declared the test over. So this is an option to shorten your test times, especially in the upstream direction. So that's one thing I wanted to point out as a search option. If we go back to the test setup, there are a few more things that we want to have a look at. First, when you're running a throughput test, always use UDP traffic. Don't ever use TCP traffic. The reason being is you're trying to stress the access point or the system under test to its maximum packet rate and try to uncover issues. TCP will be an inherently lossless protocol. And so if we begin seeing loss, the TCP windowing and TCP retries will come into play, and the number that you get, which will be a quote throughput number, will have been the result of the system trying to accommodate for loss. So don't use TCP, go to UDP, all right? If you need to turn on QoS, that's your ability to do it here, and you can set up your WMM and .p priority and layer 3 QoS, etc. Most of these settings down here you won't need to adjust. The connection time is automatic, but if you find that you've got an exceptionally slow DHCP server and a exceptionally high number of clients, you may need to go into custom and adjust the timeouts and the rate per second to give the device under test less of a stressful load of a number of clients all trying to connect at the same time. The number of ARP retries is just a couple here. And if you find that the network is slow to respond and you need to increase the ARP timeout, you can do that. The flow learning time is just how long do we send traffic through before starting the first test. And media contention, if you check this box, what that does is it will increase the aggressiveness of the clients getting on the air so that they're contending for the media more aggressively. I think we've already talked about the advanced test parameters here. So these are advanced throughput concepts. One more thing I'll mention is if you come back here and start doing more complex setups. So for example, we've got a Wi-Fi client group and an Ethernet client group. Most of the time you try to keep these things pretty simple where you're running 802.11ac traffic on the Wi-Fi side, one client, then you want to test with maximum number of clients to see how things work. You want to go in both directions, meaning you'll come over here to mapping and you'll choose bidirectional traffic. Once you've chosen bidirectional, it doesn't matter if you've chosen wireless to Ethernet or Ethernet to wireless. It's going to take the load and evenly distribute it in both directions amongst all of the clients that you have running. Going to a higher client count is easy to do here. Now, if you want to start running throughput tests where you have multiple client groups that have different definitions, now what will happen is the throughput test will assign the load to those clients in proportion to the phi rate that you have programmed them for. But my point here is if you get into fairly complex situations, you probably want to think about going over into Wave QoE and using the mixture of traffic and mixture of client types in order to do your next level of stress test. Benchmark testing is often done best when you have kind of a pure play situation, given number of Wi-Fi ports, given number of access points, all running the same type of traffic, and now what you're really trying to do is to determine the performance envelope of the device under test. Again, you have the ability to choose IPv6, turn on your WMM capabilities, and those kinds of things. If you are running very long tests in one direction, you may need to go back and turn on keep alive frames, which just sends an occasional frame in the opposite direction so that network under test has traffic going in both directions. This sometimes can help switches remember routes. If the traffic only comes in one direction, the routes can actually time out. So those are advanced throughput subjects, and that's all we're going to do on the throughput testing front.